Welcome to the SmartKeys podcast.
It's great to be here.
I had this moment yesterday that I think just perfectly sums up modern digital life. We're trying to refinance a loan.
Oh, boy.
Yeah. I'm sitting there, phone in one hand, driver's license in the other, trying to get the lighting just right so I can take a photo without the glare.
Ah, the laminate glare. I know it well.
Right. And then I had to record a video of myself turning my head left then right just to prove I'm a real person.
The liveness check. A classic rite of passage in the digital age.
Exactly. And it hit me. I did the same thing last week for a crypto exchange. And 2 months ago for rental application. I'm just constantly uploading my most sensitive documents to servers I know absolutely nothing about. It just feels, risky.
That intuition is spot on. It feels risky because it is risky. What you're describing is really the fundamental flaw of how the internet is built right now. We're all stuck in this endless cycle of what you could call identity rent. You don't actually own your digital life. You're constantly asking for permission by handing over little pieces of yourself to strangers.
And just hoping, crossing our fingers, that they don't get hacked.
Precisely. And that is why we're doing a deep dive today into a concept that claims to solve this. It's called decentralized identity.
Right.
Now, I know the term decentralized makes people's eyes glaze over. They think of, volatile crypto markets or heavy tech jargon. But stick with us. This isn't about speculation. It's about a fundamental shift in how businesses handle trust.
Okay, so to guide us, we're breaking down a really comprehensive guide by Felix Römer from SmartKeys.org.
Yeah.
The article is called Decentralized Identity, Transforming Customer Onboarding and Security. And its mission seems pretty clear. Move away from the old database model to something more like a wallet model.
And Römer's argument is so compelling because he focuses on the incentives. He's not just arguing for privacy for the sake of it. He's making the case that the way we store data now is just becoming too expensive and, frankly, too dangerous for businesses to even maintain.
Let's start with that danger. The status quo. The source material uses this specific term I liked, the honeypot problem. Can you break that down for us?
Yeah, absolutely. Picture a castle. And inside that castle, there's one vault where the king keeps all the gold.
Okay.
That's your centralized database. If you're a bank or a healthcare provider or a social media giant, you are building a honeypot. You're collecting millions of usernames, passwords, passport scans, home addresses, and you're putting them all in one place.
Which I guess makes it incredibly convenient for you as the business to manage.
Sure, it's convenient for the administrator, but think like an attacker. If I'm a hacker, am I going to try to rob a million different houses to steal $10 from each one? No. I'm going to spend 6 months trying to crack that one vault in the castle, because if I get in, I get everything.
And that brings up the second term Römer uses, the blast radius.
Right. In a centralized system, a single breach doesn't just hurt one user, it compromises millions. The blast radius is catastrophic.
We've all seen this. The credit bureau breaches, the hotel chain hacks.
Exactly. One open door, and suddenly half the population has their identity exposed.
And for the user, for me, it's just a nightmare of friction. I'm juggling 50 different accounts, re-uploading that passport photo over and over, and once I hit submit, I have zero idea what happens next.
No visibility.
None. I don't know who's looking at my data, if they deleted it when I close my account, or if it's just sitting on some abandoned server somewhere.
That's the fragmented experience. But let's look at the business side, because this is where the story often gets missed. Businesses used to think data was the new oil and asset.
Right. Collect as much as you can.
But Römer points out that today, a lot of that data is actually toxic. It's a liability.
Toxic data.
Personal Identifiable Information, PII. The second you hold my passport scan, you are now on the hook for GDPR in Europe, CCPA in California, and a dozen other compliance frameworks. You have to pay for secure storage, for lawyers, and if you get breached, massive fines. You're holding a ticking time bomb you don't actually need.
And then there's credential stuffing. I hear this term a lot in security briefings. How does that fit into this honeypot theory?
It's the aftershock of the explosion. So let's say a retail website gets hacked. They lose your email and your password.
Okay.
Hackers know most people reuse passwords, so they take that stolen list and run automated scripts against banking sites, email providers, corporate logins. The breach at the little retailer cascades into a compromise at the big bank.
It's a domino effect.
A huge one.
Okay, so the diagnosis is grim. Users are annoyed and exposed. Businesses are paying to hoard data that might just blow up in their faces. So let's pivot to the cure. Decentralized identity. How does this actually fix the problem?
We invert the model. It's that simple. Instead of the data living in the castle, the data lives in your pocket. The core idea is shifting ownership from the institution to the individual.
The source uses the wallet analogy. But I want to be specific, because people hear wallet and they think Apple Pay or Google Wallet. Is that what we mean?
In terms of user experience, that's the goal. But the plumbing underneath is totally different. Apple Wallet holds a digital copy of a credit card, but the bank still controls it. If the bank freezes your account, that digital card is useless.
Right.
With decentralized identity, we're talking about an identity wallet where you hold the keys. It's a digital vault on your own device.
Okay. So in this world, I don't have a separate login for every website.
No, you have one identity that you bring to the website. And to understand how, we need to break down the 3 pillars Römer outlines in his piece. The first is the Decentralized Identifier.
Simplify that for me.
A DRI is like a permanent, unique phone number for you on the internet. But unlike a Facebook profile, which Facebook owns and can delete, this is a number that you generated and you control. It doesn't depend on any central company.
Okay, got it. Pillar 2.
Verifiable Credentials, or VCs. This is the actual stuff in the wallet. These are digital, cryptographically signed versions of physical proofs. Your driver's license, your university diploma, your employee badge.
Signed by who?
By the issuer. That's pillar 3, kind of. The university is an issuer. They issue a diploma VC to your wallet, and they sign it with their private digital key.
Okay.
You store it. Then later, you go to a job interview. They're the verifier, and you present that VC. The employer just checks the signature and knows instantly, yes, this came from Oxford and it has not been tampered with.
Okay, now we have to talk about the elephant in the room. When people hear crypto decentralized, they immediately think blockchain. So I need you to be crystal clear. Is my passport photo going to be uploaded to a public blockchain for the whole world to see?
No, absolutely not. And thank you for asking that, because it's the single biggest misconception, and the source material is very emphatic about it. Your PII, your name, your address, your photo, it never, ever touches the blockchain.
That is a huge relief. So what is the blockchain even doing then?
It's just a trust anchor. Think of it like a public bulletin board. The university posts their public key, their public lock on that board. When they sign your diploma with their private key, the employer just looks at the public board to see if the signature matches the lock.
So it's for verification, not storage.
Exactly. It's used to verify the issuer and to check if a credential has been revoked. But the data itself, that stays in your pocket, shared directly, peer-to-peer.
Got it. Okay, let's talk features, because this sounds great for security, but usually more security means it's harder to use. The article calls selective disclosure a killer feature. This sounds a little like magic. How does it work?
This is my favorite part, because it totally changes how we think about privacy. Let's use the classic bar example. A bouncer needs to know if you're over 18. You hand him your physical license. What does he see?
Everything. My name, my exact birthday, my home address, my height.
All of which he does not need. He just needs a single bit of information. Age greater than 18, yes or no? With selective disclosure, your wallet takes your credential, performs a kind of mathematical proof on it, and sends the bouncer a simple yes.
So he just sees a green check mark on his screen.
A green check mark. He doesn't see your birthday. He never sees your address.
That's the zero-knowledge proof idea, right?
That's it. It sounds like a contradiction proving, something without revealing what it is,
Yeah.
There's a great analogy called the cave analogy. Imagine a circular cave with a magic door in the back that needs a secret code. You want to prove to me that you know the code, but you don't want to tell me the code. So you walk into the cave through one entrance. I wait outside. A minute later, you come out the other entrance. The only way you could have done that is by opening the magic door. You've proven you have the secret without ever whispering it to me.
Wow. That is what my wallet is doing, but with math.
With very complex math, yes.
That's incredibly powerful. You're building trust by actually sharing less data.
Exactly. And that flows right into the other big feature, passwordless onboarding.
The dream.
Isn't it? Think about the friction of signing up for a new service today. Name, email, confirm email, create password. No, it has to be more complex. It's awful. In this model, you just scan a QR code.
Right.
Your wallet pops up and asks, do you want to share your verified email and name with this service? You hit approve with your face or your fingerprint. Done. You're logged in.
And because it's reusable, I don't have to type it all in again for the next site.
Verify once, reuse everywhere. It just kills form fatigue.
Okay, but is this real? I feel like we've been hearing with the death of the password for a decade. Is anyone actually using this stuff?
It is happening, but it's largely invisible to most consumers for now because it's starting in the enterprise and government space. The source cites Microsoft Intra-Verified ID. They're using this for things like verifying new employees or onboarding students to a university.
And there was a government example, Estonia.
Estonia is the poster child. Their e-residency program is built on this. It lets people have a government-backed digital identity to start EU businesses and sign contracts no matter where they physically live. It proves this can scale.
Okay, so the tech works, but let's put on our CFO hats. Why does a business adopt this? We talked about the risk of holding data, but is there an ROI beyond just, safety?
There is, and it's a big one. It falls into two buckets,
Yeah.
security and efficiency. Security we've covered. If you don't hold the PII, hackers can't steal it from you. Your attack surface shrinks.
Lower insurance premiums, less liability. Makes sense.
But the efficiency side is huge. Think about KYC, know your customer. If you're a bank, you spend millions on manual compliance. You have teams of people looking at PDFs of passports, checking for Photoshop. It's slow, it's expensive.
And probably full of errors.
Very. With verifiable credentials, that whole process can be automated. The system checks a digital signature in milliseconds. It costs a fraction of a cent, and this is key. It drastically reduces fraud.
Because you can't Photoshop a cryptographic signature.
You can't. You can fake how a document looks, but you cannot fake the private key of the U.S. government or a major university. It makes creating those synthetic identities that criminals use so much harder.
There was a strategic point in the text that really stuck with me, and it was about AI. We're living in the age of deepfakes. I mean, I saw the video of a CEO announcing a product that didn't even exist. It was completely AI generated. How does this help?
This is a frontier. As AI gets better and better, our own eyes and ears become unreliable. We can no longer trust seeing is believing. We are going to need cryptographic proof of humanity and of provenance.
Provenance.
The origin story of a piece of content. If a video comes out from a news organization, how do you know it's real? In the future, that video file itself will be signed with the organization's verifiable credential.
And my browser would just check the signature.
Your browser will check it and give you a little green check mark. Verified source. Without that cryptographic layer, the internet just becomes a hall of mirrors. We won't know what's real and what's fake.
So it's not just about logging into a website. It's about anchoring reality itself.
It's a defense mechanism for the truth.
That's a heavy thought. But let's ground this again. It all sounds pretty utopian, but the source material is honest about the challenges. Why aren't we all using this already? What's the catch?
The biggest catch is just human behavior, UX friction. People are creatures of habit. We hate passwords, but we understand them. The idea of managing a digital wallet, of being responsible for your own keys, that's a big mental shift.
And the big question, what if I lose my phone? If my entire identity is in that wallet and it falls into the ocean, do I just cease to exist digitally?
Yeah, that's the recovery problem. And it's critical. In the early days of crypto, if you lost your key, your money was gone forever. We can't have that with identity. The industry is solving this with something called social recovery.
How does that work?
You designate trusted guardians, maybe your spouse, your lawyer, and a close friend. If you lose your wallet, you can initiate a recovery process. If a majority of them approve it, you can restore your identity to a new device. It sort of mimics how we vouch for each other in the real world.
And then there's the issue of all these different systems talking to each other.
Interoperability, yes. If my license is in my Apple Wallet, but the rental car company only accepts Google's system, the whole thing falls apart.
So it needs standards.
We need universal standards.
Yeah.
The source mentions groups like the W3C and the Decentralized Identity Foundation, the DIF. They're working on it so that identity can be like email. You can send a message from Gmail to Outlook, and it just works. Identity has to be the same.
Looking forward, the article ends with this shift from static documents to living credentials. What does that mean in practice?
Well, a PDF scan of your diploma is static. It's dumb. It doesn't know if the university revoked your degree 5 minutes ago for plagiarism. A living credential is dynamic.
How so?
When you present it, the verifier can do a real-time check against the public ledger, the revocation registry.
So if I get fired, my digital employee badge could stop working instantly.
Instantly. The badge in your wallet might even update to reflect that status change. It allows for real-time trust, not trust based on a piece of paper from 3 years ago.
That's a huge upgrade. But the source does throw in one last caveat, referencing CrowdStrike.
Right. The caution is that we have to be careful not to just rebuild centralization in a new form. If we all end up using one company for our wallets or one single verifier, we've just recreated that single point of failure.
Defense in depth.
Always. And even with perfect ID tech, you still need anomaly detection. Just because the ID is verified doesn't mean the person using it isn't doing something weird. You still need all the other security layers.
Okay, so we've covered the honeypot risks, the wallet mechanics, and the future of, well, proof of humanity. For a business leader listening, a CTO, a product manager, what's the one thing they should do today?
Don't try to boil the ocean. You don't need to rip and replace your whole identity system overnight, I would say. Map your high-friction verification points.
Look for where people are dropping off.
Exactly. Where are you asking customers to jump through hoops? Where are you losing 20% of your signups because they have to go find a document and scan it? That's your starting point. Pilot a wallet-based solution there, measure the lift.
Start with the pain, prove the value, and then expand from there.
That's the strategy.
Well, this has been a fascinating look into how we might finally kill the password and actually own our digital lives. I want to thank you for tuning in to the SmartKeys podcast.
It has been a pleasure diving into this with you.
And if you want to get into the weeds on the technical specs, I really encourage you to read the full article by Felix Römer. We've put the link right there in the show notes. It's a comprehensive guide that lays out the whole strategy in detail.
It's definitely worth the read for anyone working in this space.
And hey, if you enjoyed this deep dive, make sure you subscribe to the podcast. We're covering the future of work, SaaS tools, and all the insights you need to stay ahead. Thanks for listening, and we'll catch you on the next deep dive.